So arrays and vectors. What is an array? It's a list, it's a series of values. So for example, this definition here looks the same as it did before, except we use these square braces here to say that we're going to have 5 elements in our array. And then it goes out and it allocates enough RAM, asks the operating system for enough RAM to hold 5 integers. And since each integer is 4 bytes long, that'll be 20 bytes, right? There, 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 and there. So let's go and in our lecture N file, let's make that int test subscript 5, right? Now we want to initialize the values to the values 0, right? So we're going to do this, just so that it's all full of zeros. Now, honestly, if you want to fill it all full of zeros, you can just do that as well. But I'm going to leave it the way it was, right? Maybe it's clear. So those are our values. And if we do this, we ask for the size of the array, it's going to tell us that it's 20 bytes using namespace std, right? Let's add the word bytes here. Now, what if we want to know the length of the array? Well, in Python, we just used len, right? Like that. Well, we don't have an len function in C++. We have to calculate its length. And the length of the array is the length of its bytes divided by the length of an int, or divided by the length of one of the values of the array, right? So we could declare something called num items, and it's equal to the size of the array divided by the size of an int. So num items is equal to num items less than ENDL, like that, right? So it'll tell us that it took 20 bytes. And since the machine's running amazingly slowly, compiling is running amazingly slowly as well. Okay, so if you want to change one of these values, you do it by its index. Test subscript 0 is equal to the number 200, right? Except you don't put quotes around it because these are ints, not strings. My mistake. Test subscript 1 is equal to 300. Test subscript 2 is equal to 400. Test subscript 3 is equal to 500, right? And test subscript 4 is equal to 600. I just picked those numbers at random. Can I allocate a test number 5, right? No, I cannot, because it's 5 elements long. Indexes start with 0, and so I can do 0, 1, 2, 3, and 4. Can't do 5. Now I could print those items out if I wanted to, right? I could do cout, test 0, test 1, test 2, but instead I'm going to use a for loop. So for parentheses, int value colon test. For every value in the test array, see it out. That's printing by value, right? That's a for each loop, a for value loop, right? For every value in the test array, so it would print out 200, 300, 400, 500, 600. Looks like the compilation's done, and so the old version is actually running. I may not be getting to run my programs very often until I get to fix whatever is wrong with my laptop. All right, so anyways, it was 20 bytes long, and the number of items in it is 5, as predicted, because 20 divided by the size of an int, which is 4, is 5. There seems to be this conversion going on in the background, and that seems to be killing us. But I don't want to cancel that, although I probably should. Things would probably work better. Yeah, let's do that. All right, is that going to help it? Not a lot. A little bit. Windows 10 is taking up more than 100% of my processes. It's got a serious problem. Well, I'll have to diagnose it later. Okay, so anyways, we can print out the values that way. Or we can print them out by their index. You know, for each loops are great, right? They're easy to write. That's very clean, easy to read syntax. But sometimes you need the index number. So like for int I is equal to 0, I standing for index. I is less than the number of items, right? But let's just copy and paste this instead. I is less than size of test divided by size of int, right? That's the number of items. I plus plus. I don't like the name of that array being called test, so I'm going to rename it. I'm going to right click on it and choose rename and call it array. All right, just to make things clear. All right, and so that changed everything, right? There we go. All right, and so I'm going to see out the index number followed by a space followed by the array at that specific value. And so we see that item 0 is 200, item 1 is 300, item 2 is 400, item 3 is 500, and item 4 is 600, right? Let's even print out the address. Let's see if we can get the address out. So let's print out ampersand array subscript I. Forgot my double arrows, right? There we go. And let's print out the word index. Okay. That's a lot. Maybe put some of that on the next line. All right, now let's run it again. And we should get a lot of information about the array. We should get the which byte each element is saved at and its contents as well. Right, so index 0 at that is equal to 200, 300, 400. Sure would have been nice if I'd put a space there, right? All right, so I think that's good enough. Now I made this way too complicated, right? I put a whole bunch of things. The simplest loop for printing it out would just look like this, right? For int value colon array. Nope, that's a for each loop. Let's do it like we did below. For I is equal to 0, I is less than size of array divided by the size of an int, semicolon, I plus plus, and then C out array at subscript I in the L, right? Like that. That's a for index loop. And this is printing with a for each loop. The textbook may call it a range-based loop or something like that. Most people call it a for each loop, right? For each value in array. Some languages even use the word each. in it, for space each, not C++. Okay, so here we're going to print out showing the memory addresses, pointers, as well as the index, subscript, and value. So that's what we're doing there. And so we see that the addresses, although these are in hexadecimal, not integers, right? Not decimal, so it's a little bit harder to read. We could probably convert it to an INT and it would be a little bit clearer. But anyways, we can see that every 4 bytes is the next element in the array. So at element at address CA4, there's a number, and address CA8, there's a number, and then 4 more, and then at B0, there's a number, and at B4, right? So every 4 bytes. So back to that slide, right? It's just like, see if we can get both of these on the screen at the same time. It's like this first element is that address, and this second element is that address, and this third element is that address, and so on. So they're consecutive, right? That's what an array is. It's a consecutive series of values in memory. They give a slightly definition. It's a variable that can store multiple values of the same type, stored in adjacent memory locations. I use the word consecutive. Adjacent works just as well. And they're declared with that. So let's play with this a little bit more. I'm going to go in and make an array called days. It's going to be an array of string. Now, if you're going to use an initializer list, you don't even have to specify a size there. You can, but if you leave it off, it'll figure it out from what's between, whoopsie, what's between the curly braces. So like Monday, Tuesday, Wednesday, Thursday, and Friday, right? 5 days in this week. And we're going to have an array called sales, which is an array of doubles, right? Well, how many sales are there? Well, tell you what, let's just create a variable to hold the number of days and the number of sales. So let's declare const int num underscore days equals 5. Because then we could use this in all of our for loops, and we could use it to allocate our arrays, right? Like that. And our sales are zeros, right? So just filling in the first number with a 0, the rest of them get reset to 0 as well. So wipe out the array, right? Reset the array, right? Leave it all zeros. If you don't, it's just got garbage memory in it. Some languages, when you declare an array, Java does this, it'll go ahead and set all those values to 0. C++ does not do that by default. Okay, and now let's ask the user for the sales for Monday and Tuesday and Wednesday and Thursday and Friday. And then let's set a sales amount for that day. So let's use a index-based loop. I is equal to 0, I is less than, you see that, num days, num underscore days, I plus plus. Let's see out a message. What were these sales for, followed by the day name, right? So days subscript I, and then a question mark, telling them where to type. And then we're going to let them type it in, right? So we're going to CIN into sales subscript I. Store the result in there. Now we could print out a table. Now we could calculate the average sale, right? Let's do that. Let's calculate the total of the sales. I like to store my totals in a double so that I don't get floating point rounding, you know, or excuse me, I don't get integer rounding down when I calculate the total. So for every value in the array, for each in the sales array, total plus equals the value. Okay? Don't even need curly braces there because it's just one line of code. And then what's the average? Average is equal to the total divided by the num days. Now let's print out our array. And we're going to try to make it look slightly pretty. So we're going to go ahead and use the IO manipulators. Include string. We're not using strings right now, but we could have been. # include IO manip, right? And we're just using IO manipulators so that we can arrange things in columns. So let's see out a blank line to start our report. And then let's see out, let's set the width of this column to 3 and call it days, right? Because it's going to say Monday, Tuesday, Wednesday, Thursday, Friday, followed by a space. And then let's see out the name of this column, but it's going to be the word sales. You know what, if it's just going to be the word day, we don't need to set its width. But I'm going to go ahead and do it anyways. Right? We could have done all that on one line. Now let's print out a next line of dashes to make a pretty array, right? Excuse me, a pretty table. And again, since it is only 3, specifying at 1, 2, 3. But what if we later gone back and we made these, you know, 4 words, Monday, Tuesday, Wednesday. Wednesday's the longest name. How many letters are in Wednesday? Is that 9? Yes, it is. Okay, so anyways, might want to set it to 9, right? Okay, now let's use a for loop. It needs to be an index-based for loop because we need the index number to hook up our days array with our sales array, because the first day is index 0, the first sales will be at index 0. The second day will be index 1, the second sale will be index 0, right? You know, and we could have filled it in like that to make it absolutely clear, the correlation, right? That index 0 matches that index 0. That index 1 matches that one. This one matches that one, right? And so on. But that syntax looks a little sloppy, so why don't we just leave it the way it was? So for I is equal to 0, I is less than num days, I plus plus, right? So we're going to see out. Let's set the width of the day to 9, followed by that actual day, which is day subscript I, followed by a space. Where'd our space go? Right, okay. Followed by the sales. Well, you know, it might be longer, might be more than 5. What if we sold up to, how many spaces is 9999.99 equal to? Well, it looks like 7. 1, 2, 3, 4, 5, 6, 7. Right, so let's change this to a 7. One, 2, 3, 4, 5, 6, 7. Okay, and so set W7 followed by the sales for that day, right? Sales subscript I, followed by ENDL. Now this isn't going to look perfect, and we haven't set the precision, and we haven't set that we want it fixed, and we want to do that, right? Because our numbers are going to be floating point, and we want to display 2 decimals each time. So C out fixed, and then C out precision, set precision 2, right? Display 2 decimal points. That's what we want to see. let it run. So it's going to ask us the sales for Monday, Tuesday, Wednesday, Thursday, and Friday. What were the sales for Monday? Well, if it wasn't hidden behind the bar there, you'd be able to see. Heavy sigh. You're not going to crash on me again. Okay, fine. I don't know how to stop it from doing it. Ah, finally, it came back. Great. What were the sales for Monday? I don't know. $555. What were the sales for Tuesday? 300 and, yeah, whatever, right? All right. And there's our little report, right? There's our days, and then there's our sales. I think that looks pretty good, but when we did it, we always did 3 digits before the decimal point and 1 after, right? And that's not the best test. Let's run it again. Like the first day, we sold a heck of a lot. So we're going to sell $9,000 the first day. $9,000. The next day, we're just going to sell 0, right? And then 12, 13, 14. Yeah, that's looking pretty good. That's looking miraculously good. I'm pleased with our little report there. We could mess with it a little bit more. If you wanted to push the word sales against that column, you could figure out how to do it. But there we go, right? I think that looks pretty good. Now, we didn't print the average, but we could do that, right? See out total sales, $, you know, by the total, and then see out average per day, $, followed by the average, followed by ENDL, right? Let's move this calculation of the total and the average closer to where we print them out. And maybe we want to print a blank line above them, right? All right, so the sales for Monday, you know, 9,820, 400, 888.88, right? And there's our sales. Average of 2,000 a day. There's our total. Okay, I think that looks pretty good. So this was an example of a parallel array, 2 parallel arrays, right? Sales and days are so-called parallel arrays. What are parallel arrays? Parallel arrays are 2 or more arrays of the same length where the items are linked by their index subscripts, right? Let's do some silly examples. So let's make a names. Let's declare a constant to hold our names, all right? Constant int number underscore names is equal to 3. That's enough to really prove the point, isn't it? And string names is equal to, you know, Abe, Bob, and Carol, right? Like that. And then their favorite snacks, right? Snack subscript 3 is equal to, well, you know, Abe likes acorns. He's kind of a weird kid. You know, Bob likes broccoli. Also kind of weird. I'm just kidding, right? And Carol likes carrots. Those are the 3 snacks we're giving out. We're pretty weird. We could even make this asparagus just to be really weird. Asparagus. I hope I know how to spell these words. I may be misspelling broccoli. We're changing that to baked beans. All right. So there we go. And I'm changing that to apples. Okay, there. Now I've ignored the fact that I didn't know how to spell those words. All right, now let's print out a table, right? See out a blank line, see out snack list, right? See out need a for loop, right? And it needs to be an index for loop. Use an index for loop to print out or to process parallel arrays because you need that index number to access the corresponding items. So for int I is equal to 0, I is less than num names, I plus plus, right? And we can see out the name. So name subscript I, followed by the words likes to eat, followed by their snack. Snacks subscript I, followed by a period, followed by ENDL. So sales for Monday, Tuesday, Wednesday, whatever, right? Okay, so Abe likes to eat apples, Bob likes to eat baked beans, Carol likes to eat carrots. So again, those are parallel arrays. Names and snacks are parallel arrays, where Abe likes apples, Bob likes baked beans, and Carol likes carrots. I guess we could move this comment up near where we declare them. Abe's data is subscript 0, right? Bob's data is at subscript 1, and Carol's data is at subscript 2. And remember, the words subscript and index are the same thing. All right, let's go look. So the number 5 is called the size declarator, right? We're going to declare 5 integers. The 5 is the size declarator. And what's the size of the array? Now, to me, I would just say it's 5. But that size of function returns the number of elements times the size of each element. So since these are ints, 4 times 5 is 20. If they were doubles, since doubles are 8 bytes long, 8 times 5 is 40. And so the size of the array is the total number of bytes for it, but the number of elements is the total number of bytes divided by the size of each one. And that's why you use the size of operator. It's a good idea to do it like this in this language, because there's no direct way to ask the array how long it is. There's no len function. Declare a constant that contains the size and then declare it out to that. That makes it easy. Later on, if you want to change it, like what if you wrote all your for loops just to say for I is equal to 0, I is less than 6, because there were 6 pieces of data in your array. But then later on, you went and you added some more pieces of data. You'd have to go and change all those 6s to something else. But if you declare it as a variable, a constant, then you can just access it by that. So accessing array elements is done by their index. The subscripts start at 0, 0, 1, 2, 3, 4. And the last element is n minus 1, where n is the length of the array, right? So if that array is 5 elements, we can access index 0, 1, 2, 3, 4. N is the length of the array, and minus 1 is the largest subscript you can access. If you access past the end, past that subscript, past 4 in that particular case, then the program can crash or print out invalid data. So array elements are just the same thing as regular variables. You know, just like you can do int nums is equal to, and then create an array, right? 8 comma 6 comma 7 comma 5 comma 3 comma 0 comma 9, right? Like that. Let's declare a size const int. Let's just call it size is equal to 7. Stick that in here. So just like you can do, whoops, it's supposed to be a caps, isn't it? You know, just like you can do x is equal to 1, you can say y is equal to nums subscript, you know, and pick one of those, right? Any one of those. Just like you could do z is equal to 3 plus 4. You could say int a is equal to nums, you know, 2 plus nums subscript 3, right? Whatever, right? You can use these elements, you know, nums subscript 4 is equal to nums subscript 2 times 1, right? We're messing it all up, but whatever, right? Array elements are treated just like variables of that type. For example, we can use the nums int array elements as we can any other int variable. And you do have to access the elements via individual elements. You can't say print out tests. Now, some languages actually do that, right? That work in Python. Instead, you have to use a for loop to print them out or some other way. So you can access each element using a literal, right? Like that 3, or you can use a variable. And that's what we've been doing in our for loops, right? I is equal to 0, I is less than whatever. Print out that element at subscript I. So you can use an array, a for loop to step through it. And that we've done this several times. Remember I showed you an alternate syntax where if you don't need the index number, you can use the alternate syntax, which just looks like this. For int value in the numbers array, you know. But in this case, it looks like they actually need the index, right? So this tactic that I'm showing you here would not work, but just for printing them out, see out, you know, that value followed by DL. That's a value based for, yeah, that's a for each, a value based loop. So what does this code up above do? It just steps through it up to the size of the array, 0, 1, 2, 3, 4, setting each element to 99. Yeah, copy that and paste it into our notes. That didn't work. Try again. Right click. Right click, paste. All right. Declare an array, that's what we're doing here. Declare an array called numbers and set each element to 99. That's what this loop does. We must use an index-based for loop to do that because the subscript is necessary to access the items to change them. Now print the numbers. Since there's no pressing need to know the index, just use a for each loop. So a closer look at the loop, we start our value out at 0 because we want to hit the last element, excuse me, the first, and we keep going while it's less than the array size. So if array size is 4, this would count 0, 1, 2, 3, 4. Default initialization. If it's a global variable, all the elements are initialized to 0 by default. And I sure wish that local arrays were the same. But actually, local arrays do not get a default value of 0, and we can prove that really fast. What if we printed it out before we initialized it to 99? Well, we're going to see some weird numbers. We're certainly not going to see 99. There they are, right? At negative 8 billion or whatever that number is, right? It's just uninitialized memory. When C++ asks the computer to give it some memory, it doesn't erase that memory first. Now, Java and Python do, but this one doesn't. Now, if it was a global variable, if we made these global variables, and I'm going to undo this, right? But I'm going to go up here and temporarily make them global variables. Then when I print them out, they're all going to be 0. And that's what we see, right? So global arrays get initialized to 0, but local arrays do not. Now let's undo all these changes I've made. So that's worth making a note of. If an array is declared as a global variable, all the elements are initialized to 0. Otherwise, if it's a local array variable, the elements are uninitialized. And you'd better initialize them before you use them. Better set the values before you use them. But we did see a way of initializing it, right? If we did this, I'm getting tired of ints. Let's use some doubles, right? So DA for double array. Const int DA size equals 10, right? And then let's allocate our array out to that. Now they usually make their constants in caps. Sure, whatever. Like that. Now let's give it some values, right? 1, 2, 2, 3, and 4. But I'm not going to define any more than that. This sets it equal to an array that's 4 elements long. That's what gets allocated, but only the first 3 elements are initialized. Then what happens to the rest? The first 3 are initialized to these values, but the rest of the values are set to 0. Let's print it out now. For double value in the DA array, except you don't use the word IN, instead you use colon, see out that value, followed by ENDL, and we will see that it says 2, 3, and 4. Let's put a blank line here, right, because our output's getting messy. Right, and so we got the values 2, 3, and 4, but the rest of them were set to 0. So we can take advantage of that to initialize an entire array to a zeros if we want to, right? We don't have to write a for loop to set them all to 0. We can take advantage of the fact that the unspecified, or that the remainder of the array past the end of the initializer list to set the entire array to zeros. So DA or double DA2, DA size is equal to 0. Now the entire array is 0. Why? Because the first element gets a 0 copied into it, and then the rest of them all are wiped out to 0 as well. And let's write out a for loop to print them out, just to make sure that that's the case. Print out for every value in DA2. Print out a blank line first. Right, and they all got set to 0 as promised. Now it's not because this one is a 0 that they all got reset to 0. If we set that one to 1, they're not going to all get set to 1. Only the first one's going to get set to 1, and then the rest of them will be left at 0. Just like that. All right, I hope that makes sense. Let's set that back to a 0, because that's the point of the comment there. So you can build an initializer list like that. That's what we've been doing. Here they initialize an array of days, right? Days of the month, 31, 28, 31, and 30. Hope it's not a leap year, or else that 28 is wrong, right? January has 31, February is 28, March has 31, April has 30, all the way up to December having 31, right? And so it says month 1 has that, month 2 has that, month 3 has that, and so on. To get it to say 1, 2, and 3 rather than 0, 1, and 2, they are adding 1 to the count, right? They're printing out not count, but count plus 1. Partial array initialization, I just explained. This array is 7 elements long. We specify the first 4 in our initializer, and so the rest of them are left to 0. All right, let's think about some homework for what we have talked about. What have we done? We have talked about arrays. We also talked about pointers and stuff like that. I think I'm okay with leaving that alone. I don't know. Maybe we ought to do something with data structures. Or maybe we'll leave that for next Monday's lecture. Yeah, why don't we do that? Because we'll talk about classes and we'll talk about data structures again. And so let's us instead do homework based on arrays, because that's what we spent most of our time talking about. Write a program that creates an array of strings named movies and initialize it to contain 5 of your favorite movies. Print that array out with a for loop of some kind. I'd recommend a for each, but if you want to use a for index loop instead, that's fine. So that's part 1. That's real easy, right? That only takes you, a couple of lines of code. So part 2 is going to be more complicated. It's going to look a lot like that sales. Remember when we did Monday, Tuesday, Wednesday, Thursday, Friday, and we did sales? So part 2. Whoops. With that there, it's no longer part in a comment. Write a program that asks for the total rainfall for each month, like this. What was the rainfall for January? Or if you just feel like using Jan, that's fine. And you type in 20. What was the rainfall for February? 12 inches, right? What was the rainfall for March? 10.5, right? And so on, et cetera, et cetera. The program then prints a table showing the rainfall for each month and the average. So, month followed by rainfall. So January had 20.0, right? February, oh, come on, had 12.0. March had 10.5. Let's change one of these. Let's make that say 2, right? I think that looks pretty good, et cetera, et cetera. Average rainfall was, and whatever it turned out to be, 17.321, something, etc. Okay, so my comment, this code will look almost precisely like the sales per day code in the lecture. So if you can't get that one done, at least do the first part, because the first part's only going to take you a couple of minutes, right? If you can't make your report as pretty as this, just print out the day and the rainfall, right? You'll get majority credit even if it's not as pretty as that, right? You can probably still make an A even if you're just printing the day and said January has 20 inches, February has 2, and March has 10, whatever, right? It doesn't have to be that pretty. But it'd be nice if it did, right? So go ahead and try. And this code up here demonstrates how to do that using the IOmanip functions. Where was that? Right there, right? Using fixed and set precision and using the set width and so on to make everything pretty. So you'll be able to do that pretty easily, I think. If not, if you get stuck, let me know. All right, does that make sense? All righty. All righty, I will see y'all next lecture. All righty, see ya. Wait, I didn't send you the second lecture. All righty.